strength in the relationship between two numerical variables. We're going to do this using a calculation called correlation. So correlation, specifically in this setting, must refer to a linear relationship. So if you draw your scatter plot and it has some kind of curvature associated with it or clustering, anything but linear, forget it. You cannot use this calculation to measure strength. So it must be linear. And then another important reminder must be the relationship between two numerical variables. This is not appropriate if you have a numerical and categorical. There's other types of measures of strength there. So correlation, relationship to numerical variables that have a linear relationship. So when we calculate correlation, we should always be getting values between -1 and 1. And as an example here, suppose I have a value of -1. This -1 means it's a perfectly negative relationship, perfectly straight line with a negative slope. So let's jump down to number 2 here. This example, r equals -0.99. You'll see the slope is negative, and the relationship is very strong. It's almost a perfectly straight line. Then, if you have a correlation of 1, that means it's a perfectly straight line with a positive slope. So looking at the top row, I've got positive slope, and it's a fairly strong relationship. It's very close to 1.95, fairly strong relationship. And then as we move away from -1 to 1 and get closer to 0 in the middle, the weaker the relationship will become and the more scattered. So here, 0.18, it's very scattered. I'm much closer to 0 here. -0.39, we can see a negative trend, but it's very weak, especially compared to that -0.99. So closer to 1 or -1, perfect line. You move closer to 0, it becomes much weaker. And the positive or negative just tells you the slope or the association. A few more things to pay attention to. Correlation has no units. Okay? No units because it's calculated using z-scores. And z-scores, as we learned earlier, also have no units. Next thing, it doesn't matter how you assign x and y because we're multiplying z-scores together. I won't show you the calculation in this video, but just know you're multiplying z-scores together. So 2 times 3 is the same as 3 times 2. So it doesn't matter which is x, which is y. Then a very, very important comment here, correlation does not imply causation. If you need something interesting to look at, this website has all kinds of interesting correlations that he collected from various other websites. Just to show you a couple of examples, this bottom one, the per capita consumption of margarine and the divorce rate in Maine are apparently highly associated. And you'll notice here on each of these examples, the common factor is time. So there might be something else going on in time as well. So these are kind of silly and out there, but just remember the big idea. Just because two things have a very strong correlation near -1 or +1 doesn't necessarily mean that changes in one variable is causing changes in another. All right, like I mentioned, I'm going to skip this idea behind it, how it's calculated by hand, and let's take a look at how to find this on your calculator. So on your calculator, before we do that, we're going to go back to the egg yolk data. So if you need to, let's flip back to that scatter plot of the amount of egg yolks versus the cholesterol in a particular recipe. I hope nobody's hungry. And we want to get a measurement or a calculation for what the strength is of the relationship. So look at this and think for a moment, make your guess, and jot it down here in this guessed correlation. We'll see how close you can get. All right, so now we need to find the actual correlation using our calculators. So first thing, we need to enter the data. I have it here below for reference. Yolks was our X variable, maybe label it that way. X is our egg yolks, Y is the cholesterol. So we're going to go to the place we've been a few times before, Stat, and then just press Enter on Edit. And we'll get our list here to put the data in. Remember, if you have it populated with something else, you can press up and highlight L1 and just press Clear. Don't press Delete. You don't want to delete the entire column, just clear. Looks like nothing happens. Press down and it's cleared out for you. So everybody, let's take a minute and enter in our egg yolk data. Let me double check it to make sure nothing was skipped. And it's very important that these are, the X's and Y's stay in the same order. Okay, that looks good. And then let's hop over to the second list and put our Y values in. Again, you can't just put them in any random order. They're pairs of points, so they need to stay in the same order here. Once you're done, just double check it to make sure everything is okay. Alright, so I've got my pairs of points in, X in list 1, Y in list 2. Now, you'll notice in your notes there's a step 0. Your calculator will not display correlation by default. We need to change that setting first. I call it step 0 because after you change the setting with me right now, we don't need to do this anymore. It's already been changed, we're good. So we're going to press second, that blue button at the top, catalog, which is number 0, so second, catalog. And then we're going to scroll down for a little bit until we get to the D's, and we want to find diagnostics on. And that will allow it to display additional information. Once you find diagnostics on, it might take a second to get there, so diagnostics on, just press enter. It'll show up on your screen. Press enter one more time and it says done. So we've changed the setting and your calculator should now show correlation. Now we're almost done. Let's go to, we've already entered the data, so let's go back to stat. Now we want to calc. And you'll notice there's two different regressions. There's this number 4, linear regression, AX plus B. You could use that, but for future sections, we're going to use this option number 8, A plus BX. So I'm going to just get in the habit of choosing that one right now. So I'll press enter here. X's, we entered egg yolks in list 1. Y's, we've entered the cholesterol in list 2 already. So we're good to go. Let's just calculate. So press calculate. And you'll notice all kinds of information. We'll talk about all of this at some point, but for now, let's focus on R. The last entry here is our correlation, 0.83278 if we round it. So go ahead and write that here in your notes. 0.83278 is our actual correlation. And I'm curious how close it was to your guessed correlation. Did anybody do a good job getting pretty close to that value?